Yeah, welcome back everyone. So this is part 2 of the exploratory data analysis series. Okay, so in this we would be focusing on visualization and getting different insights out of the same data set we used in the last video. Okay, so the most important libraries here would be two libraries, Matplotlib and seaborn. Okay, so let's quickly import Matplotlib and also import seaborn. Okay, and then also we would be needing numpy. Okay, because some of the the parameters need array as an input, like for example in pi, because this is the I would go through this. So this is the matplotlib.pyplot official documentation. You just search for pi and you get this. And then what I noticed here is that for x, it's a 1D array. Okay, so I don't want to be want you to be confused about what is an array. Okay, so let's cover some basics of numpy as well here. Okay, so bear with me for some time, and yeah, I mean, let's get started. So we would cover visualization as the main thing here, but we would be giving some introduction of numpy as well. Okay, so how to define an array in Python, and what is an array? Okay, so you'll see that in a second. Okay, so there's an array function in numpy. Okay, so you just passed in a list in this. So this is a list. Okay, so you're passing a list in a np.array function. Okay, so you get oh sorry, okay, I should have run this cell. Let's say the np is not defined. Now it should work, right? So now if you want to take a look at it, I mean, you can just go ahead and print it out. All right, so that looks like a list, but a list has commas in between, right? It's a sort of a different structure, I would say. Okay, very similar to list, but not exactly the same. Okay, so you can so one important thing is that okay, so you can also like make arrays of different dimension. So what I mean by different dimension, you would see it in a second. Okay, so this is also an array. Okay, 1 2 3, and then so let's go 4 5 6. All right, and then let's pass this and then print it. Okay, so this is a 2-dimensional array. Okay, so this is 1 dimension, and like if we had some vertical, so that would be the second dimension. Okay, second dimension for 1 dimension, 2 dimensions. Okay, so there are 2 dimensions to this, right? You can make multiple dimensions like that. Like you can make as many dimensions as you want. Okay, but I think that's not something we are concerned about here, because we might go into depth into numpy in some other video, but here we just need to understand what is the difference between what is a 1D array. Okay, so I just showed, like I've shown you 2D array. Okay, just for the sake of sort of being able to differentiate how they're different. So this is ndim. So this basically allows you to see what is the dimension of the array. Okay, so if you sort of print, so you can be sure like of the dimension. Okay, so this is 2, this is 1, right? So yeah, so without going like deep into the numpy, okay, so numpy has pretty cool like things you can do with numpy. You know, there is a lot of linear algebra stuff you can do with it. We would get into that later. Okay, so for now, I think let's stick to the visualization part. Okay, so we want like, so what we wanted to do was that, yeah, so let's see, this is the data we have. Okay, so what we want to do here is that we know that there is a legendary column. So you want to see what is the distribution of legendary versus non-legendary Pokemon in this data frame. All right, so think about what a pie looks like. So a pie is basically percentage of, it would be proportion of legendary and proportion of non-legendary Pokemons, right? So we just need, you can say that 80% of the Pokemons, like, I'm assuming that, okay, I don't know, 80% of the Pokemons are legendary and 20% of the Pokemons are non-legendary, all right? So then that would sort of fit into the pie, and that would be a very good representation, all right? So let's try to do something of that sort. And we want to pass in a 1D array as 1D array, like, okay? So it's something like 1D array, okay? So we want to pass, okay? So this is pld.py function. and we want to pass in a 1D array. For now, I'm commenting this because we would need to sort of create the thing we would be passing in this. All right, so yeah, okay, so let's try and so what all the concepts we will be using here are relating to pandas, which we already covered in the previous video. So if you haven't watched that, I would provide the link in the description. You can check that out. Okay, so yeah, so without any further ado, let's like start with this. Okay, so let's try to separate the true rows here in this data frame. Okay, so we use the log function, and then we go ahead and use this. Yeah, sorry for an extra comma, and then you write it as true, and then you copy paste that. All right, and this time we want it as false rather than true. All right, and then let's name it as F. Cool. So, but now what is T basically representing here? So T is representing, it's a data frame. Okay, so with all the rows which have legendary as true, and similarly, if you see F, it's also a data frame which has legendary false rows. All right. So, but we don't want a row. We instead want something like a count, right? So let's apply a count function here. Okay, and try to see what does that do to the T. Okay. Yeah, so we got the count. All right, so you can ignore type 2 because it has some missing values, as we noticed in the previous video as well. So, but you can see that there are 65 counts for all wherever there is legendary as true, right? So we have, so technically that implies that we have 65 legendary Pokemon in our dataset out of total 800 Pokemons. All right, but we want just the 65 number, not this. I mean, this is like a column of a data frame. All right, so we don't need this, so we can fetch it by just, so I think I should clarify this. So we can fetch 65. Okay, so that's what we want right now, correct? So if we print T of 0 by indexing, you can always Google stuff if you get confused, like how to fetch this. So even I figured it out like the same way when I was learning Python. All right, so you can just fetch any value out of this. Actually, I'm just taking 0 because that's convenient. All right, so you do the similar thing with this, and then check what is F. Yeah, yeah, so we have 735. Okay, so 735 plus 65 is 800. So we have covered all the Pokemons. So some of them are legendary and some of them are not legendary. All right, 65 are legendary and 735 are not legendary. Okay, so we only have 65 legendary Pokemons. Okay, that's not something to be happy about. But yeah, okay, so the next thing is that we want an array, right? So what we can do is, let's keep this commented only for now. Okay, so what we did, like when we define an array, we pass the list inside the np.array function. Okay, so let's do the same thing here, np.array, and then let's pass the list. What is the list this time? Okay, so the list is T and F, because that's what we want as an array to pass into the pie. All right, I hope it's making sense. If you have any questions, you can put it in the comments. All right, so I think that should give us a pie. Yeah, we got a pie. Okay, but there are no details to it. We'll add details to it, don't worry. Okay, so this is annoying, right? So we can get rid of this by using pld.show. Yeah, so we have this. Okay, still there's a lot of information missing. Like it would be great, like we don't know what percentage is this and what is this basically, the yellow portion and what is the blue portion. Okay, so there's a function called labels. Okay, you can definitely look in this. What is labels? So labels are basically, it would help you identify what is this orange portion or what is it blue portion. There are a couple of examples. Okay, you can definitely not here, but I mean you can find it in the documentation itself. I don't remember exactly. So sometimes if you get stuck, it's even good to Google about it. Okay, it's quicker in some scenarios. Okay, so the first thing we have is legendary. For now, let's stick to this. If you have any questions, you can for sure put that in the comments, and I would definitely try to answer that. Okay. So we have first as legendary, so I'm putting it in the same order, right? And the second as non-legendary, which is F, all right? And then we have a function which we can pass here, sorry, a parameter, all right? Labels equals to labels, all right? And then, yeah, that should do the job. Yeah, that's it. Okay, and then supposedly we also want a title. Okay, so we have a plt.title. Then what do we want? Distribution of legendary Pokemon, right? I mean, that makes sense, correct? We can even change the size of this, you know. Let's say size equal to 10. We can even change the font. Okay, we can do a couple of things. You can use the documentation. Okay, I think it should. Let's try the size to be 50 and see if it's working. Yes, it is working. Okay, I was doubtful. I could not see the difference when it was 10. I think by default it was 10, so that's the reason. Yeah. So the thing is that we can even change the font of this. Okay. But I don't think, I think there are a couple of other important things I want to talk about before that. Okay, so adding some, like if we had percentages displayed here, that would have helped us a lot. Okay, so let's see how can we do that. Okay, so actually I knew this. Okay, so if you would search, you would be probably searching PCT or percentage. Okay, so that's what the thing is. Okay, so sometimes it's difficult to sort of find things in the documentation. So what you can do is how to get percentages in pie chart Matplotlib, right? So you can just search for it. Okay, so there's something like auto percentage, something. Okay, let's try this. Let's try luck. And then, damn, does that work? Oh no, okay, wait. We did something wrong. All right. What is the error? Okay, we have, okay, do we need one more? Okay. Is that it? No. Okay, sorry, I got it. Okay, so this is, we missed that while copying that. Okay, now that should work. Yeah, that works. Okay, so we have the percentages now, right? Okay, so okay, so there are multiple things we can do with this. Okay, so we can even change the figure size. Okay, so fig size is the parameter. Okay, so we need to give 2 dimensions, you know, length and breadth. Yeah, okay, that's huge, but yeah, that's fine. And then the next thing we can also do, I don't like the style of this by default. Okay, so we have a function called plt.style.use. Okay, so there's a ggplot style, okay, which I like much better. I think that's inspired from, I'm not really sure, but I'm guessing it's something to do with the R programming language has ggplot. I remember, I don't know. Yeah, so you can look it up if you want to see what exactly like what exactly is ggplot. All right. Yeah, but that's not of concern here, I guess. I mean, this is looking smaller given we have increased the size of, yeah, that looks better. Okay, yeah, so we have the percentages and everything looks good. So we know that most of the Pokemons are not legendary and only some Pokemons are legendary, which makes a lot of sense because they're legendary, they have to be less in number, right? Yeah, so that's what is unique. That there has to be something unique about the legendary Pokemons, right? So yeah, I think that's it for the pie chart. Okay, so let's explore something else. Okay, so let's try something called a scatter plot. So we need numerical variables for that. Okay, so let's try for HP and attack. Okay, and then let's also search the documentation. Okay, scatter. Yeah, here it is. All right. So matplotlib.pyplot.scatter, and then we have x and y as the parameters. Okay, so we have 2 parameters we need to pass. Okay, so it does not really matter what is the shape of the array. All right. Okay, so let's do that. Okay, so I think we can directly call in the columns here since the shape is not something of concern. So let's call HP and attack. Well, let's see if that works. df HP and df attack. Does that give you a scatter plot? That does. All right, that's good. plt.show. Okay, yeah. So we'll get rid of that. Yeah, that looks good. Okay. So also what we need is we want to sort of get a bigger figure. I would say fig size equals to 10, 10. Yeah. Okay, that makes more sense. All right. So we also need labels. I would say plt.x label. So this is the label for the x-axis. Okay, this is a parameter which we can pass. And then what is in the x-axis? We have HP, and what is on the y-axis? We had y label as attack. All right. So and also we can specify the title. plt.title scatter of HP and attack. All right. We can even change the font size. We can do that for labels as well, but I mean that's not something very significant. You can look up in the documentation. I think there is a couple of cool stuff we can do with this. Okay, so the important thing here is that you need to observe that most of the values for attack are between 150 and 25, and for HP they're just between 0 to 100. Okay, so right now not even 0 actually. Somewhere around 15 to 20 to 100. All right, so yeah, this is also one very important thing that this scatter plot tells us, is that there is somewhat of a positive relation, not linear in some sense though, not very linear. Okay, but yeah, there is some positive relation. We can also be sure of the same by using the correlation table. All right, so we have attack and HP, right? So if you see attack and HP, okay, so yeah, this is a positive correlation of 0.422. All right, which is also evident in the scatter plot. Okay, the scatter plot is somewhat more detailed than this table. Obviously, this captures a lot of details as well, but it's sort of hard to read. Okay, and this is specific if you want to see things about HP and attack, like if you want to see stuff for two variables specifically, and you want to focus on that. Okay, so this is something very good. Okay, and okay, so when you see the correlation table, okay, so this is sort of very hard to read, I would say. So what we can do is, okay, so there is a very cool feature in the seaborn. I think we have already imported that. Yeah, we have that in the seaborn library, something called as heat map. Okay, heat map. All right, let's confirm if that's how we do it and what are the parameters. All right, okay, so we have ssc1.heatmap, and then data is obviously something we need to enter, and then x tick labels, y tick labels, and stuff like that. Okay, well, you can change colors, you can do a lot of things. Okay, so let's firstly put the data. Okay, so what data do we want to plot? Okay, so as I talked about it, so correlation is pretty well represented by a heat map. So let's pass df.correlation as our data and see what we get. Amazing. Okay, so again, you can write plt.show to get rid of this. Yeah, so even you can even write plt.figure fig size equals to 10. I write this above sns.heatmap. Okay, so this is something to note. Okay, so if I sort of write so if I comment it here and write it here, so it won't work because it has already plotted the heat map. Okay, so you need to specify this before. Okay, so that's an important thing to note, which I think I did not mention earlier. All right, so you can see. Okay, so this represents similar stuff. Okay, So this black color is basically almost zero correlation, and this one is very high correlated. So you can see all the variables with themselves are obviously correlated as one because they are exact same variables, right? Total and total is one, HP and HP, and similarly the whole diagonal, all right? And then you can see like which variables are pretty like even the generation and the number of Pokemon is somehow pretty closely related. Okay, so also remember that these are only the numerical columns because you can only compute this for the numerical columns. So this takes only numerical columns. Uh, okay, so yeah. So the other thing is that, so you can see like this is the bar which helps you to see what is the correlation. Like almost it's 0.6 for HP and total if you see. We can see for HP and attack as well, HP and attack, all right. So HP and attack is almost, yeah, somewhere here. As we noted, it's 0.442, okay. Yeah, so one other thing we can do with this is there is some pretty cool feature which sort of, I think it's not equals to true that does that. Let's see, yeah, so this writes down the values, okay. So values of the various correlations. As you can see now, we can see attack and HP is 0.42. So that's sort of easier to read now, I guess. Okay, so there are plenty of things you can play with. That you can change the color scheme of this and do a lot of stuff, okay, if you want to do that, okay. But yeah, I think you can read the documentation and get to know more about how to do this, but I think this gets the job done, all right. So yeah, I think that's all for this video. Okay, so we will be continuing more about more with box plots and also some other analysis in the next video. And also even we missed on the histograms, right? So even we would even try to do that, and there would be something related to group by as well, which we would be covering and relating it to the histogram plot. Okay, so stay tuned and keep liking the content and subscribe if you feel that the content I share is of value to you and you are liking and enjoying that. So stay tuned and see you. Thank you for watching, and yeah, have a great day.